2024 A-Level Combined Mathematics Paper 2 Part B Question number 11 Part A. Part B of this same question will be discussed in a future video, link in the top right. Part A of this question has to do with velocity time graphs. The question says, a car P that begins its journey from rest on a straight road from a point O at time t equals 0 seconds moves with a constant acceleration of f meter per second squared for 5 seconds. After this, it then moves with the constant speed that is attained at t equals 5 seconds for another 5 seconds, and at t equals 10 seconds starts to decelerate at a constant deceleration of f meter per second squared, and finally comes to rest at point A. The car P then changes direction instantly and starts to return towards the point O with the same constant acceleration of f meter per second squared on the same road. So if we consider this motion, the car P starts somewhere on the road at a point O at time t equals 0 seconds and starts accelerating on the road at f meter per second squared acceleration until it reaches time t equals 5 seconds, at which point it continues with that same constant speed for another 5 seconds, and at t equals 10 seconds starts to decelerate in this direction at again f meter per second squared until it comes to rest at a point A, and after coming to A, it then starts to accelerate in the reverse direction by changing direction instantly and starts accelerating towards the point O like so, with again f meter per second squared acceleration, and goes like that, and we are not told when it stops, we are just told it continues accelerating towards O in that direction with that speed. Now after this, the question says, another car Q that begins its journey with an initial speed of 10 f meter per second, not at rest, with an initial speed from the point O again at t equals 10 seconds, moves towards the car P with a constant deceleration of f meter per second squared along the same road. So here, the car Q is moving starting from the point O towards the car P like so, with an initial speed of 10 f meters per second, but as it travels, it is decelerating like so in this direction at f meter per second squared. Now with this, the question says, it is given that the distance between the car P and the car Q when P comes to rest at the point A is 125 meters. It then says, sketch the velocity time graphs for the motions of P and Q from t equals 0 seconds until they meet in the same diagram, and given this, we are asked to show that first, the value of f is 10, and second, the cars P and Q meet at time t equals 17.5 seconds. Now with this, what they're saying first is that at the time at which point the car P comes to rest at A, the distance between P and Q, which I'm going to interpret as this distance here, is 125 meters. Secondly, given this information, they are asked us to first find that f is equal to 10, and second, find that when P continues moving this direction and Q continues moving this direction, when the two meet a certain time later, like this, which I'm going to call t equals t0, and here also t equals t0, at that point, the time t equals t0, when the cars P and Q are on the same point on the road, is going to be t0 equals 17.5. So this is what we have to prove. And to prove that, we need to first sketch the velocity time graphs for the motions of P and Q from t equals 0 seconds until they meet at t equals t0 in the same diagram. So for this, I'm going to sketch quickly a velocity time graph and draw both the velocities of P and Q with respect to time from t equals 0 until they meet at t equals t0, and we're going to sketch that and figure out what we can use from that diagram in order to find the values of f and also the value of t0. So let's go. So as you can see here, I marked the vertical and horizontal axes as velocity and time respectively with their units of meters per second and seconds respectively. In addition to that, I've also marked some important times: t equals 0 seconds, 5 seconds, 10 seconds, 15 seconds, and t0 seconds, which we're going to be using in order to draw our graph. Now for this, what we're going to do is to first consider the motion of car P and use that to draw the velocity time graph corresponding to car P. So reading the question, car P begins its journey from rest on a straight road at time t equals 0 seconds. So according to this, if the car is at rest at that time, it is going to have 0 velocity. Therefore, the velocity at t equals 0 seconds is also equal to 0. According to that, on our graph, the origin, the 0, 0 point, is going to be one of the points that are on our velocity time graph of the car P. So the car P starts at 0 velocity at t equals 0 seconds. Now after this question says the car moves with the constant acceleration of f meter per second squared for 5 seconds. Now if we apply v equal u plus at to the situation, v is our final velocity and it's equal to u plus at, where here u, our initial velocity, is 0 since our car is at rest. So we have 0 plus acceleration times time, where the acceleration here is equal to f meters per second squared times the time, which is equal to 5 seconds. So according to this, we can see v equals f times 5 or 5f. Therefore, the final velocity after accelerating for 5 seconds of our car at t equals 5 seconds is equal to 5f meter per second. So going down our graph, I can mark this as at time t equals 5 seconds, which is this point right here, the velocity of our car was 5f meter per second. So on our vertical axis, I'm going to mark a point which is completely arbitrary here, and I'm going to call this point the height of 5f on the time axis, or rather velocity axis of meter per second, and I'm going to say at t equals 5 seconds, which is this vertical line right here, the value of velocity was 5f meter per second, and therefore this point is a point on our graph. Now in between these 2 points, since our car had a constant acceleration, the gradient of the line in between these 2 points must be constant, and therefore it is a straight line. So I can draw a straight line in between the origin, the 0, 0 point, and the next point, which is t equals 5 seconds and velocity equals 5f meter per second. Now after that, the question then says the car continues at this same constant speed attained at t equals 5 seconds for another 5 seconds. So what this means is that from that time of t equals 5 seconds, our car continues without changing its velocity, meaning it goes at the same exact velocity with 0 acceleration for another 5 seconds until the time of t equals 10 seconds. So therefore, until this time of t equals 10 seconds, which is this point right here, our car continues at the same constant velocity. So until that point, we can draw a straight line, a straight horizontal line on our velocity time graph corresponding to a constant velocity of our car. Now after that, the question says at t equals 10 seconds, the car starts to decelerate at a constant deceleration of f meter per second squared. Now if we consider that situation, we can see at t equals 10 seconds, since our car was still traveling at the same constant velocity it had at t equals 5 seconds, the velocity at this point is forward direction 5f meter per second. But after that, our car continues to decelerate until it gets to the point A, at which point its velocity in the forward direction is 0, since it comes to rest at the point A. Now if we consider this motion, we can see applying v equals u plus at here, the final velocity v is 0 since our particle is at rest at the end of the journey. So therefore, we have 0 velocity at the end. So 0 is equal to u plus at. Now in this situation, u, the initial velocity, is equal to 5f meters per second. So we have that plus at, and here, since our acceleration is actually a deceleration, meaning it's in the opposite direction of our motion, which is the positive direction, its actual value is negative. This way is positive, and therefore since we're accelerating the reverse direction, the f here is negative. Therefore in our equation, when we substitute, we need to substitute this acceleration as negative f meters per second squared, and then that is multiplied by the total time taken to slow down until we get to rest. Now according to this, we can see if we rearrange, we get 5f equal ft, and therefore dividing both sides by f, we get t equals 5, and therefore the total time taken for our car to decelerate and become velocity 0 again at rest at the point A is equal to 5 seconds. So according to that, if we go down and in our graph draw the motion after this point, we are going to have a line downward from the point 10 seconds and 5f meter per second all the way down to 0 velocity at t equals 15 seconds. So this is going to be the shape of our graph from t equals 10 seconds until t equals 15 seconds. Now after this, finally the question says the car continues accelerating towards O in that same direction by instantly changing its direction after it stops at the point A. So it keeps accelerating in the same direction towards O even after stopping and starts moving forward in the direction of the particle O, or rather the point O. Now according to that, if we consider a velocity time graph, since acceleration is the gradient, we can see the gradient of the graph from t equals 10 seconds until 15 seconds and the gradient of the graph after t equals 15 seconds are both going to be equal, since the same acceleration of f meter per second squared in the direction towards O is there before and after we come to rest at the point A. So according to that, to draw the rest of the graph, I can simply take this graph right here and extend it further like this until we get to t equals t0, at which point we were asked to stop drawing the graph because that is the point at which the two cars meet. So until that point I can extend it, and I'm going to have this point right here where our acceleration is in the negative direction of negative f, and we go from 15 seconds until t0. So according to that, I can actually draw something here. I can draw that the velocity in the negative direction of our car at this exact point, which is this value on the y-axis here, is the total time taken, which is t0 minus 15 times the acceleration, which is negative f, and I can write that as negative f times t0 minus 15 seconds. So this is the velocity of our car in the negative direction at the point at which the two cars meet. And with that, we are actually done with drawing the motion of car P in this diagram. So now I can label this motion as the motion of car P and continue to car Q. So I'm going to mark this as motion of car P and go up and read about car Q and make car Q's graph. So considering car Q begins its journey with an initial speed of 10 f meter per second from the point O, but it begins at t equals 10 seconds. So for the first 10 seconds, car Q doesn't even exist on our graph. So therefore, in all of this space here, we are not going to draw anything for car Q. Instead, we only started drawing stuff for car Q at the time t equals 10 seconds. Now considering t equals 10 seconds, at that point, our car starts with an initial velocity of 10 f meter per second from the point O and is moving towards car P. So if it's moving towards car P, which is somewhere over here, from the point O, it is going to have been moving in this direction, and therefore its initial velocity is positive. So we can mark it as a positive value of 10 f meter per second. So in our graph, if this is 5f, then about double that distance upward, which is somewhere over here, we should mark the velocity of 10f, and horizontal to that, at t equals 10 seconds, we can mark our first point on the graph of the car Q, which is going to be this point right here. T equals 10 seconds and velocity equals 10 f meter per second. Now after the question says the car begins to decelerate with a constant deceleration of f meter per second squared along the same road. Now the same deceleration of f meter per second squared was there for car P after t equals 10 seconds. Now as we know, the gradient of the graph in a velocity time graph is equal to its acceleration or deceleration. According to that, if both car P and car Q have the same deceleration from t equals 10 seconds onward, both of their lines in the graph should be parallel to each other as they have the same gradient. So therefore, in this graph, I need to draw a line from this point that is exactly parallel to the line that is corresponding to the motion of the car P from t equals 10 seconds forward. So for this, since I am doing this digitally, I'm actually going to take this line, copy it, paste it, and bring it over here. And now I have a parallel line to the line of the motion of car P, which is car Q's motion from t equals 10 seconds forward. So I can actually mark that additionally also, and I'm actually going to mark that just because I can. I'm going to mark that this line and this line are both parallel to each other. Now, since they haven't given us any other information about car P, we are going to assume that car P will continue to decelerate like this until car P and car Q meet, or rather car Q will continue to decelerate like this until car P and car Q meet at a certain point on the road at t equals t0. So therefore, at that point in time, I can mark another point on the graph of car Q's motion and mark that as the final point on car Q's graph. So with that, I can mark this line right here as the motion of car Q. And with that, we are basically done with drawing a graph. The only other thing I do here is to mark all of the special points in this diagram, because we can easily use them in order to find the motions of these particles and also their distances much more easily later. We can refer to the areas under the graphs by points rather than saying the area under the curve of this car until this time, something like that. So here, since the point O and P, A and Q also, all of these symbols are taken, I'm going to start labeling my points with B, because if I use A, it'll be confusing. So I'll label this first point here as the point B. I'll label this point as the point C. Maybe I'll label this point as point D. This point as point E maybe. Maybe this is F. I think this might be important, so we'll call this point G. We'll call this point here H. And we'll also call this point here I. And with that, we are done with labeling the points in this graph, which we can then later use in order to find the areas under the curves of these graphs and make it much easier to refer to these graphs later. So if I want to, say the area under the curve of car P's motion, I could just say area of the parallel or the trapezium O, B, C, G, or something like that. So now we are done with drawing the velocity time graph and can try to figure out how f is equal to 10 seconds or rather f is equal to 10 and cars P and Q meet at t equals 17.5 seconds. So let's go. So for the first part of the question, in order to show that f is equal to 10, we are going to be using the fact that when car P comes to rest at the point A, the distance between cars P and Q is equal to 125 meters. Now if we consider our velocity time graph, we can see that car P comes to rest at t equals 15 seconds. And therefore, when it's at the point A, the time is t equals 15 seconds. According to this, the total distance traveled from the point O to the point A by car P must be equal to the total area under the velocity time graph of the motion of car P from t equals 0 seconds until t equals 15 seconds. So therefore, the total area, which is this area from t equals 0 seconds to 15 seconds under the graph of the motion of car P, is equal to the total distance OA. So going down, I can write something like distance OA equals distance traveled by car P from t equals 0 to t equals 15, which is also equal to the area under the curve, which is the area of the trapezium O, B, C, G. So it's also equal to area O, B, C, G. Now similarly, I can make a conclusion regarding the motion of Q. Now considering Q, since Q did not appear until t equals 10 seconds, I'm going to assume it was at rest at the point O until that time. Now after that, from its motion in 10 seconds up to 15 seconds, we can see it has a velocity of 10 meter per second and decelerates at f meter per second squared. Now according to that, until the time t equals 15 seconds, it is continuing to decelerate. So therefore, if we consider total distance traveled within that time, it is going to be the area under the curve, which is going to be equal to the area of this trapezium right here. Now I'm going to make a little edit to what I did previously. I'm also going to mark this additional point right here at t equals 15 seconds on the motion of car Q. I'm going to call that point, we've used I, so I might as well call it J. So this point is J. Now with that, the total distance traveled from the point O until the stopping point of car Q is equal to the area under the curve, which is the area of the trapezium D, J, G, H. So similarly, I can say distance traveled by Q from t equals 10 seconds, well it's 0 seconds, but we are just ignoring that bit. So we can start with 10 seconds to t equals 15 seconds is equal to the area d, j, g, h. Now if we consider these motions, we can see this is the distance traveled by car Q, this is the total distance traveled by car P, and the difference between them is the distance given, which is 125 meters. And therefore, the difference between the area under the graph of car P's motion from t equals 0 seconds to t equals 15 and the motion of car Q from t equals 10 to t equals 15 must be equal to 125. So therefore, the difference of these two areas is equal to 125. So we can say, therefore, area OBCG minus area DJGH is equal to 125. Now with this, all we have to do is to find the two areas, substitute them in, simplify, and then find the value of f. Now if we consider the first area OBCG, we can see the area of OBCG is the area of this trapezium right here. And as we know, the area of a trapezium is equal to its height multiplied by the average of the two parallel side lengths. Now in this case, we can see the height of this trapezium is equal to 5f and the two parallel sides are BC and OG, and BC has a length of 5 and OG has a length of 15. So therefore, our area of OBCG is equal to 5f times the average of 15 and 5, which is 15 plus 5 over 2. Then you have to subtract off the area DJGH, which is equal to the area of this trapezium right here. Now considering this trapezium, we can see the base length is going to be equal to 5, which in this case is going to be considered the height here, and we also have this and this parallel sides, where this side is equal to 5f and the other side is equal to 10f. So therefore we have 10f plus 5f over 2 times the height, which is going to be 5. So therefore, the area DJGH is going to be equal to 5 seconds multiplied by the average of 10f and 5f, which is 10f plus 5f over 2. And that must be equal to 125. Now to simplify this, I can multiply everything by 2. Multiply by 2, I can see on the left hand side, I get 5f times 15 plus 5, which is 20, which is going to be equal to 100f. So here we get, for the first area, 100f. So on the left side we get 100f minus, and then second one, if we multiply both sides by 2, we're going to have left 5 times 10f plus 5f, which is 15f, and 15f plus 5 is 75f. So here we get 75f. But on the other side, when we multiply by 2, we are going to be left with 125 times 2, which is 250. And therefore we get 100f minus 75f equal 250. Now simplifying, we can see we have 25f equal 250, and therefore finally we can see f must be equal to 250 divided by 25, which is 10, and therefore the value of f is 10. Now we can move on to the second part of the question, which says show that the cars P and Q meet at t equals 17.5 seconds. So for this second part of the question, I'm going to be considering the total displacements of cars P and Q from their starting time until they end their motion by meeting at a certain point on the road. Now if car P and car Q meet at a certain time t equals t0, at that time t equals t0, they must be at the same exact point on the road. Now according to that, if we consider displacement of car P and car Q from the point O on the road, at time t equals t0, both of them should have the same displacement from the point O at time t equals t0. Now according to that, if we consider the velocity time graph and consider in that context, the total area, total assigned area under the velocity time graphs of both the motion of car P and the motion of car Q must be equal to each other at time t equals t0. So according to that, the total area under this graph of motion of car Q and this graph of motion of car P must be equal to each other at t equals t0. Now in this we have to remember the area is signed. The area above the x-axis is positive and the area below the x-axis is negative. Now according to that, if we consider two areas here, the area relevant to displacement of car Q is going to be the area from t equals 10 seconds until t equals t0, and we are ignoring everything else because of course the car Q didn't start moving until t equals 10 seconds. So therefore the area relevant here is this area right here. It is the area of this trapezium in which I'm noticing right now one of the points is missing. So I'm going to label this point as point, let's say, K. So therefore, the area relevant here is the area of the trapezium DEKH. So this is the displacement of the car Q from the point O until time t equals t0. Now similarly, we need to consider the other displacement, which is the displacement of car P, which will be equal to the area under the graph of the motion of car P. Now here, part of the area is above the x-axis, which is positive, but part of the area is under the x-axis, which means it's negative. So here, the area of this little triangle GKF is negative, but the area OBCG is positive. So therefore, the total displacement of car P is going to be equal to this area OBCG minus the area GKF. Now considering that, we can see going down, since car P and Q are at the same point when they meet at t equals t0, the total displacement of P must be equal to displacement of Q. So therefore, we can say displacement of P from t equals 0 to t equals t0 is equal to displacement, and we can do same thing for Q, displacement of Q from t equals 0 to t equals t0. And according to that, the signed areas that I just talked about must also be equal. Now for the displacement of P, as I said, we have area OBCG minus area GKF. So therefore, we can write area OBCD, so OBCG rather, minus area GKF, I believe, GKF for the displacement of the car P. So therefore, we can say the area OBCG minus area of GKF is equal to the area relevant to the displacement of Q, which is equal to this area right here. And that area is the area DEKH. So you can write equals area DEKH. Now I could just leave it like this and simplify and get an answer, but instead I can do some simple area rearrangement. Now here we can see we have a common area right here on both of these graphs, and therefore we could try and get rid of the common area, since if you equate them with the common area or without the common area, it's still going to be equal. So the common area here is the area CHG, and if we remove that from both areas, for the area of P, we're going to have this area OBCH and minus the area GKF left over. And if we remove from the other one, we're going to have this area left, the area DEKGC. Now here I can do another thing. Since the area GKF is subtracted from the left hand side, I can add it to both sides and put it on the other side, in which case on the left hand side we only have the area OBCH, and on the right hand side we have the area here plus the area under the curve, which means the total area would be area DEFC. So with that simple rearrangement, I can say, rearranging these areas, the area left on the left hand side would be area OBCH, which is equal to the other area which we get when we take this bit GKF to the other side and add it to the area DEKH, in which case the total area we get is this area plus this area, which is the area DEFC. So area DEFC. So area OBCH is equal to area DEFC. And now we can equate both sides. So on the left hand side we have area OBCH, which is the area of this trapezium right here. Now in this trapezium, the height is equal to 5f, and in terms of the other side lengths, they are 5 and 10. So therefore the area there is 5f times the average, which is 5 plus 10 divided by 2, which is equal to the other side, in which the area is equal to this total bit, which is equal to this height here, which is there on both sides, is parallel on both sides, and both sides should be equal therefore, and both sides we have this 10f minus 5f, which is 5f. So since it's a parallelogram, if this side length is 5f, then the other side length is also 5f, and therefore both sides are 5f. So we have 5f plus 5f divided by 2 as the average height. Now considering the other side, the other height, this height, is equal difference of t0 and 10. So therefore we have t0 minus 10 times the average of 5f and 5f. So the area of this parallelogram, which we can write in terms of trapezium, is equal to 5f plus 5f divided by 2 times t0 minus 10. So we can write t0 minus 10 times 5f plus 5f divided by 2, and that is our equation. Now into this equation, we can substitute the value of f and simplify down to get the value of t0. So doing so, we can see on the left hand side, we have 5 times 10, which is 50, times 15 divided by 2, which is equal to, and on the other side we have t0 minus 10 multiplied by, and here we have 5f plus 5f divided by 2, which is 5f, and f is equal to 10, so therefore we have 50. So we have times 50 on this side as well. So here we can see the 50 and 50 cancel, leaving us with 15 over 2 equals t0 minus 10. So therefore t0 is going to be equal to 10 plus 15 over 2, which is equal to 10 plus 7.5, which is 17.5. And therefore our two particles meet, our two cars meet rather, at the time t equals 17.5. So finally we can conclude that cars, we can say therefore cars P and Q meet at t equals 17.5 seconds. And with that, we are done with this question. Now finally, let's go up and discuss the marks order for this question. So at the start of the question, when you draw the velocity time graph, for the first part of the graph from 0 seconds up to 5 seconds, if you draw it correctly, you get 5 marks. After that, when you mark the velocity as 5f and mark the flat line from 5 seconds to 10 seconds of the motion of car P, like so, you get another 5 marks. And finally, when you mark the deceleration of car P like this and the instant change of direction like so with a single straight line, you get another 5 marks. Now similarly, when you mark the motion of car Q starting at t equals 10 seconds at 10f velocity and going down with an acceleration in the negative direction of f meter per second squared like so, and mark that correctly, you get 5 marks. Now after this, when you also mark that the exact intersection point at which the car P comes to rest at the point A is at 15 seconds, you get another 5 marks. For identifying this, you get 5 marks. Now after that, when you go down and say the distance OA, or the distance traveled by car P, is equal to the area OBCG, you get 5 marks. Similarly, when you say the distance traveled by Q from 10 seconds up to 15 seconds is area DJGH, you get another 5 marks. Now after this, when you use the information given to state that the difference of these two distances or the difference of these two areas is equal to 125 meters like so, writing this equation gets you 5 marks. Now after this, when you use the geometry to find the area of this thing and this bit and say this area is equal to 5f times 15 plus 5 over 2 and this area is equal to 5 times 10f plus 5f over 2, you get 5 marks for substituting correctly each of those areas. Now after that, when you simplify down and get the value of f equals 10, you get a final 5 marks. Now for the second part of the question, where you show that the two cars meet at t equals 7.5 seconds, at the start, when you consider the motions and say at the point that they meet, the displacement of P must be equal to displacement of Q like so, writing that down gets you 5 marks. After that, when you then equate the displacements on either side to certain areas in the graphs and you take the signed areas with them correctly written, you get 5 marks for writing the signed areas. And then when you substitute in the values of those signed areas like so, you get 5 marks. And simplifying that down, when you get the TC2 is equal to 17.5 seconds, you get a final 5 marks. And with that, we're done with this question. So I hope you enjoyed. If you have any feedback or questions, post them in the comments down below. Thank you for watching and goodbye.